Right. So yeah, let's get started. Oh, we're 6 minutes past the hour now, but let's just press on and let maybe more people will join us as the session progresses. Like just now, some people have joined. Cool. Um, Great. So welcome everybody. So this is the introducing the small uncrewed aircraft on autonomous vehicles platform working group. So this is a session organized by the Small Unmanned Aircraft Systems Data Interest Group. So we'll be discussing today about progressing that interest group into a working group. Um, so my name is Ryan O'Connor, and I'm part of RDA Europe. I am working as part of the RDA Association, specifically on the RDA Tiger project, which I'll explain a bit more in detail in a minute. I'm based in Ireland, so it's early morning here. So welcome everybody. So I can see some people joining us at the moment. I'll just give a quick minute or two sort of introduction, kind of run through the housekeeping rules, and we can get started properly in the session then. So I'll be, as well as myself speaking today, I'll be joined by my colleagues, Alice Fremont, who is working at the UK Polar Data Centre, the British Antarctic Survey based in the UK, by Jens Klump, who's based at CSIRO in Australia, and by Thabo Semang, who is based at the Botswana International University of Science and Technology. Um, Next slide, please, Jens. Cool. So as you'll have just heard the notification, this session is being recorded. It'll be available to everybody who's registered for the session, and it will be made available to the rest of the RDA community in a few weeks, I think. But as for now, it's just available to people who have registered for the plenary. So as I've been made a note here, if you please add your name to the attendee list. So I've just pasted into the chat a link to the collaborative notes document. So there's a table, possibly on the second page there. If you could just paste your name or put in your contact details and name there, that would be appreciated. As well as this, if you could just please keep your mics on mute during the times when people are presenting. There will be quite a large section towards the end of the hour and a half to work through for you to bring up any questions you have, and also feel free to use the chat function as well. I'll be monitoring that throughout the session as well. So as well as the link in the chat there to the collaborative notes, there's a QR code on screen if that's easier for you. So next slide, please. So just a quick run through the agenda. So I'll give a brief introduction brief welcome and kind of introduction to the group, and just kind of introduction to RDA as well, just for people who might be new to the organization and who might be bit unfamiliar with the difference between working groups and interest groups. I'll just give a quick overview of that for those it will benefit. I'll hand over then to my colleague Jens, who will be giving a review of the past activities of this interest group. And then we'll hand over to Alice, who will give an introduction to the new planned working group, and an update on the status of that. Then we have a brief I think it's a Mentimeter survey. So we'll be looking at just getting some responses from you on a few quick questions before we launch into some shorter, but 7 or 8 minutes reports from Thabo, Jens, and Alice, who are the proposed co-chairs of this new working group. And then towards the end of the session, we'll be opening up the discussion to attendees, and maybe have a few more questions to put to you, and just kind of get the discussion going. So we'll be inviting people to bring their concerns in, and then I'll be wrapping up towards the end as well. So yeah, Jens, if you go on to the next slide. Cheers, thanks. So yeah, as I said, I'll just give an introduction to RDA and I'll hand over to Jens then to give an introduction to the group. So next slide. So just for those who are potentially newcomers to the RDA, just what is RDA? So essentially what it is an international membership-based organization concerned with all things to do with data sharing. So really kind of focused on the development of infrastructure, and also kind of community activities that reduce barriers to data sharing and to data exchange, and kind of to accelerating kind of data-driven innovation, either within disciplines or kind of across disciplines and domain boundaries. So the focus on with RDA groups the focus can vary from very kind of discipline-specific challenges and regarding things like specific metadata standards or workflows or ontologies for specific domains or disciplines, to much broader issues kind of concerning infrastructure or policies or things like that, and also everything in between. And there's I'll go into a bit more detail on the difference on the how these issues are addressed by different types of groups within RDA in a minute or two. So RDA is a kind of membership-based organization, as I said, and it's currently has about 13,000 members globally across about 150 countries. So not only kind of researchers are RDA members, as people who are kind of data science professionals and scientists, but also people working across different fields. So I've listed here librarians and archivists, policymakers, information communications technology professionals, and everybody really who's a kind of stakeholder in research. Yeah, you can go on to the next slide, please, Jens. So as I said, RDA kind of really the work of the RDA is kind of really focused on these three group types. So there's working groups, which are more kind of focused group organizations, interest groups, which have kind of more of a broader remit, and communities of practice as well, which I won't have time to really go into this morning in the interest of time. Essentially, yeah, what these groups do, as I've said here, is just kind of explore, to exchange knowledge and share discoveries, discuss barriers and potential solutions to any barriers to kind of data sharing or data-driven innovation. It's very much kind of how would I kind of phrase it, a kind of egalitarian, I guess, organization in that anybody who's a member who joins RDA can initiate an interest group or working group. You don't have to have a level of seniority or expertise or anything to initiate a working group or an interest group or community of practice, as long as you are a member. Next slide, please. So as I mentioned earlier, this meeting is we're looking to kind of progress from the original small uncrewed aircraft systems working group, or sorry, interest group, to the new working group. So just to give a brief overview of what the difference between these two kind of organizations is for those of you who mightn't be aware or just maybe might need the refresher. So interest groups generally are more kind of open-ended organizations. So as I've said here, they're kind of platform for communication and coordination among individuals or groups or organizations with a shared interest. So they can be, they're longer term initiatives, as I've said here. They can be just a venue for people to come together and discuss issues and kind of maybe check in with other members of their community, or to maybe look at more specific issues or produce more kind of general sort of guidance. As I said here, they can kind of support communication and coordination among a cluster of, well, I've said here, related interest groups and working groups, but also kind of related organizations and kind of and wider groupings as well. And sometimes it's not always the case that these can lead to the formation of working groups. Obviously, the case hopefully it is the case in this instance, but not always that they have to kind of progress to a working group. They also produce outputs that are of value in themselves, usually more kind of, as I said, kind of more guidance or more kind of non-specific, non-technical sort of recommendations and guidance. But and then comparing this to working groups, so as I've said here, these working groups are typically more shorter term, so have a duration sort of approximately of 18 months, sometimes a bit longer, sometimes a bit shorter. And as part of setting up a working group, a group has to set up a case statement, kind of outlining in a bit of detail the working group's mission, its intended impacts, its aims, and how it's going to engage with existing communities. Really, the kind of aim is to produce something at the end of this 18-month period that is sort of practically implementable. It can be tools or policies or practices or just recommendations of some kind, but the key thing is that they have to be sort of practically implementable and adoptable and used by the projects or organizations or different communities. As I said here, these ideally at the end of the 18-month lifespan, these will produce RDA endorsed capital R recommendations, and part of this process to produce those recommendations to give proof of its implementation and adoption. And yeah, as I said here, a key thing for all RDA groups really, but especially for working groups, is this geographical diversity of the co-chairs, of the leadership of the group is key. Next slide, please, Jens. Yeah, so briefly, so as I said, I am working as part of this RDA Tiger project, which is a project funded by the European Commission. So essentially what we're trying to do with this project is to support various working groups around RDA. So this group was selected as one of the pilot groups, so to kind of to pilot our services for the project on. So essentially what we're trying to do is take the organizational burden or load from working group co-chairs and kind of help them just take that load from them, kind of help out with things around just kind of guiding them through the initial startup process, helping out with kind of any outreach activities, or any sort of engagement or landscape analysis type activities, and also kind of just taking the organizational burden from co-chairs. So just setting up things, just the more administrative type things, setting up meetings and that type of thing, and just making sure people are know what they are supposed to be doing at all points. Just I won't, no need for me to go into detail on this, but I'll put a link to this in the chat. But as I said, if you are interested in, if you're starting a working group or interested in starting a working group or know of a working group starting up or something that might benefit from RDA Tiger, we are running a sort of round the year open call. Next deadline is the end of May, but then obviously the 3 months time we'll have another deadline. So we're inviting anybody who is interested to fill out our short application form to please get apply for support. Or if you want to have any questions on what support Tiger may offer your working group or your potential working group, please feel free to get in touch with me directly or via the email at the bottom of the screen there. Next slide, please. I think this is close to the end. Yeah, so this is the end of my activity. So I hope I haven't taken up too much time. I'll hand over to you, Jens, who will give us a review of the past activities of the interest group.
Yeah, great. Thanks, Ryan, for the overview. I'll give you a bit of an overview of where this group came from and what happened until now. So the group started as an interest group in 2017, but it's actually something that grew out of the ESIP drone cluster, which started in 2015. ESIP is the Earth Science Information Partnership, an organization based in the US, but with international partners. And there's always been quite a bit of overlap between the ESIP and RDA activities. And there were a couple of interest group meetings at past RDA plenaries. But what really hit the group was the pandemic that made it not only difficult to meet and disrupted how things operated, but it also disrupted the lives of our co-chairs for this group in ways that they had to make changes to their careers that then made it impossible for them to continue chairing this group. So, but I really want to give credit to Jane Weingart and Lindsay Barberi for their activities from 2015 all the way to 2021. This graph gives you an overview of just the activities from 2015 to 2019, and there really was a lot of activity. And what we want to achieve with this session is to revive both the interest group and create a working group that focuses on a specific aspect of working with drone data. I also want to share with you this outcome from the interest group, a paper that we published in 2019 in remote sensing that looked at the particular challenges that drone data are facing and the qualities. And with this analysis, this will also help us identify specific points that the working group might be working on to look at progressing our approaches to dealing with drone data. So what this means for this group, the interest group, is that there are some changes. We have new interest group co-chairs, Alice Fremont and Thabo Simon, and I'm initiating this new working group to focus on the data coming off drones and autonomous platforms and interfacing that with the European Open Science Cloud. And I think I hand over to Alice.
Yes. So hello, everybody. So now I will introduce more specifically the work of the data working group. So Jens, if you could go to the next slide, please. Yes, so to give a bit of context, so I think you are all aware that the data, or like the drones and the autonomous platform, have become more and more important tools for the collection of data from the environment. So it's easy to bring with you on the field, and it can go where you can't. And so now, yeah, it has become very like a friend for all the scientists. And it can acquire data at higher temporal and spatial resolution and in environments that are too hazardous to work in. And with the development of the drones, but also the hardware, the instrumentation, so everything has become more accessible, but that also means that the volume of data that is collected has grown exponentially. So while cloud computing infrastructure can offer the necessary scalability and common data and metadata practice are still lacking. So the goal of the working group is to really work on the data and metadata and to see how we can improve that. And another aspect is that the use of autonomous platform in marine research is well advanced. And so we can learn from them and apply the best practices that they have developed and transfer them for the data management of data coming from the drones. So next slide, please. Yeah, so what we want to do as part of this working group is to collect use cases of data collection and processing by uncrewed and autonomous platforms from different disciplines and document best practices. So it can be best practices, but also what didn't work as well. And the goal is to then collect everything and develop recommendation for data and metadata practices. And we will focus on interoperability with like open clouds and such as and virtual research environments such as the European Open Science Cloud. So what we expect as output of the working group are specifications for metadata and data coming from uncrewed and autonomous vehicles used in research, and try to develop some small demonstrators to show how these guidelines can support the design and implementation of cloud-based data infrastructure for drones data. Yeah, next slide. So we have published I think the case statement. I think it's just from yesterday that Ryan was able to publish the case statement. And you can see everything that we are planning to do. I think Ryan can, and it's in the collaboration note, the link to the case statement. And in this case statement, we have put together this timeline where we we show the deliverables and what we are planning to do. So the first big deliverable is specifications for metadata and data collected from UAVs used in research. So first we will try to run a survey of the landscape of UAV and autonomous platform data and data processing platform, and then collect the use cases and best practices. Then another deliverable would be around the demonstrators. So the goal is to use everything that we have collected to provide this small example, and then we'll do some outreach activities. And as you can see at the bottom, there are the different milestones linked to the RDA plenaries. So we are here at the plenary 22, and this is our kind of kickoff workshop. And we'll have just a very small survey at this stage, but it's just to better know who is interested in joining. But then as part of, we will have a more consistent survey, and we will have run it through the community, and we start the specification of drone services and database and input from potential adopters. And then the next plenary will be more, so it's the 24 plenary. We'll ask for community feedback from the specification and start the demonstrators for standardized drone service and data. And then the goal is to convert this recommendation into a recommendation from the RDA. Yeah, next slide, please. Yeah, so in terms of work plan, we are planning to meet monthly in between the RDA plenaries. And we might have smaller or task-focused subwork. And we meet to focus on specific activities and use a larger monthly working group to update the rest of the working group on the progress. So I invite everybody to join us. So you can join the working group by joining the group on the RDA website. I'm not sure the working group is really live at the moment. So it is. But yes, you can also join the interest group. We might also send a bit of update through the interest group as well. Yes, so now I think we have the survey. So this is where I will try to share my screen. I'm not sure it will work, but we will try. So maybe I will try Jens, and we'll see how it goes. Yeah.
Okay, so Alice, I think you'll I'll put the link to the Menti poll in the chat here. So that should take people to the first section. So I see the thumbs up there.
Yes, so here are the instructions to join. I'm not really don't really know if it's joining.
I think it is.
will just wait 30 seconds for everybody to put the codes in and join. I will do live as well. Let's do that. And then maybe you can present, Brian, if you want it. Yeah.
So Graham saying the link is to the slide. Yeah, so I think we're good. So I think it's working so far. So and for the very eagle-eyed people, I've put a link to the slides in the chat, but the actual 8-digit code in the slides will be incorrect. But the one on screen that you're seeing now is correct, and the link in the Menti poll link that I've put into the chat is correct as well. It's just that 8-digit code in the slides is slightly out of date now, but I see there's people here. So those of you who have managed to access the link, so you should be seeing the first question now. Basically, what we're asking here is if you would like to participate in the monthly working group meetings, whether you be, we say like here, I mean, would you be available? Were you interested? Would you potentially be free to participate in these meetings? So we've given a couple of options here. So obviously yes for for people who are unequivocally interested in joining. Yes, every 2 months, because we do understand that, I mean, people mightn't be able to mightn't be sort of in the mind frame of wanting to actively contribute to the group, but want to keep up to date. So we've kind of given people the opportunity, maybe say yes every 2 months, or maybe to just kind of be member of the group, but not necessarily kind of having the time or capacity to to contribute actively. And then there's obviously the no options of if you feel that so far what you've heard isn't the group isn't for you. So there's a few options here on screen. We'll just give it another minute or two to join. So most people have said yes so far. In terms of the actual timing of this, I know Alice, you said there that we're we'll plan to hold these originally on a monthly scale or monthly basis. We haven't sort of selected a time, whether it be the kind of first Tuesday of the month or the last Friday or whatever. We haven't got around to that yet, but we will, once we get a better idea of where people are joining us from in terms of kind of the regionality and time zones, we'll look to kind of find something as appropriate as possible there. Okay, so I think that's, yeah, we can move on to the next slide. So then this is a bit more detailed. So Elise, Thabo, or Jens, please feel free to maybe explain this in a bit more detail, but just this basically just kind of asking your familiarity with various aspects of uncrewed aircraft vehicles and data curation, collection processes, and those workflows. So please feel free to be honest here, but if you're just kind of if you're quite experienced in this topic, obviously then you veered more towards the kind of 5 in terms of familiarity. But obviously if you're kind of not as new to the field, or if you're newer to the field, then maybe it might be a bit towards the 1 side of the scale. So just there's a couple of different options on screen, just, and that's those slider scales. So please feel free to fill those out. There's a few options, so we'll just give people a minute or two to submit their responses. Okay, so that's some responses so far. Okay, more veering towards the 2s and 3s, I guess. 2.5, I guess, mean maybe. Okay, that's good. Interesting. Hopefully that will be you'll be better informed once we go through these kind of lightning talks or kind of shorter presentations coming up soon. Okay, so I think the next, so we just had, those are the few questions we had at this stage. I think now we're going to go back and look at, so the next point in the agenda is the reports in the community. So essentially we're going to be inviting the 3 co-chairs to present their work and their sort of what they're bringing to the working group. So the first person who is up to present is Thabo. So Thabo, I think you've joined here, so I invite you to unmute yourself and turn on your camera if you can. And Jens, yeah, thank you for sharing the slides. So Thabo, the floor is yours.
Okay, thank you very much. Good morning. I hope it's morning on your side. So myself, I'm more involved in terms of the data collection. We really, as part of the university, we offer drone services to different clients that come our way requesting those services. So I think for this presentation, I'm just gonna give one use case where we are working with drones to collect data for the organizations or the client. And normally this data, we collect it, and then for the power inspection for Botswana Power Corporations that are dealing with providing the whole country with electricity. And because they experience some problems on their power lines, so most of the time they have been having to act in terms of repairing after the problem have occurred, but they want to be proactive to know when the problem might arise. So going forward, this data is going to be used really to optimize their process to ensure that they know what can happen or what have happened because of what, so that we can be able to add some AI to the system, and it will be able to predict to them, to say to them, when this happens, you should know what this may lead to this. So I will request maybe whoever is moving the slide. Yes, as you can see, this slide is one of the areas that we have mapped, and we are mapping this area using the drone, and this is just the map that I'm sharing. We are downloading from the GIS system, and those are the points where we are collecting the data. As you can see, these are different poles, different infrastructure for this client, and this data is on a GIS system such that after we provide them with the data, they are able to log in and check where is the problem. They are able to query the data to check how many lines on their lines, how many of them need to be serviced, how many of them has broken wires, how many of them have leakages in terms of their transformers. Okay, you can move to the next slide. And this is just the interface of the GIS system that we are using to collect the data. These are screenshots from the phones or the equipment that we use to enter the data into the system. As you can see from here, if you want to update a point, you are just getting the coordinate of the point, and then the point, like the previous page where I was showing, it can show the whole map of the area that have been mapped. And then, but each point here, it has a lot of information inside. For example, here, if you click on TX34, this is a transformer. If you click on it, then it will have a lot of field. It tell you the pole number, the installation date, the type of asset. If there is a broken insulator, it will tell you, because this is the data that we are entering. And then we can even put a picture of that equipment, and this information will be coming from the drone itself. Yes, next slide. And normally what we are picking, because the power lines, they are up the lines, you can't see them with your naked eyes. And the usage of drones have really helped, because sometimes when you have insulators like this one, they are broken and you don't know, and they are the one causing the breakage, the break of the electricity. So this has really been very helpful to the organization, because since we started offering them this service, they're able to solve this problem even before the power cuts. Hence, they are optimizing their services to the public. And as you can see, these are some of the examples of the data or the pictures that you are able to get when the drone is flying up there and closer to the lines where our eyes cannot go. Normally, some of them, they are broken on top, but when you look with your human eyes, normally you are under the pole, which means you cannot see what is happening on top there. And that is where the usage of the drones now becomes very, very effective. Next slide. Yes, this is another example. As you can see, this insulator has been bent here. And because probably there was a shortcut, and sometimes it's very difficult to see it with your own eyes. But when we fly the drone up there, it's able to pick some of this, and they really help the organization in terms of going to attend to this before anything happens. Next slide. As you can see here, this is a broken fuse. And sometimes because of this, you find that the power cannot go through, or sometimes there's a lot of leakages, as you can see here, the broken wires. So these are some of the things that since we started offering this service, they are able to pick them and rectify them before anything happens. and it has been really very, very useful to them. Next slide. I was just putting this one to just to show the what we are picking with the drones. As you can see, these pictures, sometimes the trees are overgrown, sometimes the leaves have fallen down and the bed have built. And this is very dangerous because in most cases, this can, they are shortcut, they lead to fire. As you can see here, there will be leakages and the oils. So all these things really, if they are not being attended to, they lead to power cuts. But the issue is, how do you pick them? If we don't use the drones, it becomes very difficult to pick all this now. Next slide. And the drones that we are using, they also have thermal. As you can see, these are the thermal images of the power. And normally we use the thermal during the night. We did use it during the day, but we realized that the amount of information or data we are capturing is not as good as when we are all doing it at night. As you can see here, it becomes very clear because then the corporation can know that, oh, this transformer might have a problem because sometimes it's heating up. They know what temperature they are expecting, and sometimes when we are able to pick to say the temperature is beyond what is expected, then they are able to act. And the thermal also is able to pick the leakages where there's the heat. We are able to see that no, here there is a problem of the power kind of leaking out, and they're able to attend to it. And these are some of the things that if you are not using a drone, you're going to have a problem to pick them up, because sometimes you know the output that you are expecting. We are sending the power, you are sending, let's say 300 mega. It's only to find that on the other side, what is arriving is not what you expected, and you don't know where is the leakage. And if you are not using the thermal, then sometimes it's very difficult now to pick those leakages, and this we use really for them to be able to rectify wherever there's a problem. Next slide. Yes, and the good thing with the drone is wherever we find a fault, we can always pin the location of the area, and when we download this information from the drone, we can easily put it in a map like this one, and then we give their team that is working on the rectification of the problems, and they are able to know where is the problem in terms of the coordinates, and they can go there, and before they go there, they can check on the system what is the problem in that location, and it becomes very easy now to rectify and make sure that they have a consistent power flow, because they know where the problem is or where the problem is located and what is the problem. And so that even before going there, if it's an insulator that is broken, they can bring a spare part so that when they arrive there, they can just fix it and the power continue. So normally we share with their teams some these maps so that they can follow it to go and do the rectification use, especially after the inspection, so that they can go there. Yes, next slide. Yes, this is normally what they will be following. As you can see here, it will be telling them there's a broken left disc on there, this location. There's a broken middle disc, broken what. So this is all the information that they will be getting. And they can also get into the system to get more information. But this is so far very useful, especially for their technicians when they need to go and fix the problem as soon as possible, and they don't need to get into the system now to find all this other information, because they have their GIS team that is also having access to the portal, and they can go and see what is happening, but sometimes they need to go and attend to the problems as soon as possible, and all they need is the location in the map, and they just ask for this map, and then they follow it, and then they can be able to go and attend to the problem. Next slide. Yes, this is one of the picture that we took as some of the areas that we have passed. As you can see, we're on some farmland near the city, and we're just passing through, and we saw these guys fixing the line that we just finished inspecting, and we just took a picture of them as they attend to those problems that the drone has managed to pick. Next slide. Yes, and as we go around to do the inspection, these are some of the data that we collect. Really, we will go to the pole and check the status, the insulator status, the wire status, the intrusion, the support wire, the hardware status, like I showed on the previous pictures, where we have the leakages, we have the bed nest and all those things. And safety signs, some of them, the safety signs, they have fallen down and they need to be replaced, the clearance, because sometimes there's a bushy and it's not good, because if there's a fire, then their power lines will also be affected. And most of the time they need to be clearing all those. So this is some of the information that on the portal that I showed, the interface. That is the information that will be entering into their portal, into their system. All this information as we pick it. Sometimes as the drone is up there, is getting all those information according to the coordinate. We are also entering into the system, and is also able to download some of the pictures that is getting into the interface and into the portal. Yes, and some of this information here on the right side is the one that the corporation already have, because this one we don't need to pick it through the drones. They already have it, and they can easily enter it into the portal, such that when you click a link, then you are able to pick. Yes, next slide. I think I'll be completing soon. And this is some of the information that now, once the data, the work have been done, you have all the information in the system, and you are able to query and find like the safety signs, the hardware status, and all this. This is information that you can easily now manipulate from the system after we have captured all of them through the drone and we have entered it into the system. And like I said, now it becomes easy for them to know, or to know that, oh, maybe every this number of months we need to replace this, because now they're also learning, because the whole essence of the project is not really just to pick the errors, or is also to make sure that going forward they use this data to optimize their services, like I said. Yes, I think next slide as I complete. Yes, I think this is just the drone, the matrix M330, 30 thermal that we are currently using. We think is the most suitable for this kind of inspection. But there are many other drones that we have been using for different inspections. But normally for this one, this is the one we are using. Yes, I think that will be concluding my presentation. Like I said, I'm more into the collection of the data as compared to the manipulation of the data and the data analysis of it. Thank you.
Thank you, Tabo. I'll take over from Tabo now to present a case where it was about data processing. Australia Scalable Drone Cloud, ASDC for short, was a project in the context of the Australian Research Data Commons Platforms Program. And the aim was to provide a seamless data processing platform from data capture to all the way to data publication and archiving. And you can find quite a lot of material about it at the GitHub site. The project has kind of finished now, but it will there will be a successor program, I heard yesterday, in the context of another ARDC program. So what was this about? What we wanted to do was to build this platform that covered the entire data lifecycle, from capturing data on the field, converting the individual photographic tiles into an orthophoto mosaic or a point cloud, depending on what was needed, and then given way to visualize this, and then with those data, run them through pipelines for more specific data questions to analyze the data. And then in the last step, publish the data or push them into an archive. And this is really where this platform differs from commercial applications. Commercial applications offer all of this, but never in this kind of flexibility. The commercial applications are usually very targeted at a smaller suite of applications, say around precision agriculture or surveying, but they don't allow you easily to develop new processing workflows. And also all of them are walled gardens, and it's very difficult to get data out of them and connect them to the scholarly communications, like data publications, journal publications, data repositories, and so on. And what an important aspect of this project was that we didn't want to reinvent anything. We wanted to take things that already existed and put them together into a platform. So a key component turned out to be open drone map for the photogrammetry aspects, because that was really the part that almost everybody used. Then we extended that to also help with the management of the files. And then we used Jupyter notebooks on a Jupyter hub to do the data processing, and for visualization we used Cesium and Terria. And then in the end, for the publication and archiving, it depended on the host organization and their existing archive. And all of that was then built on cloud native architecture. Because this was an ARDC project, we primarily used the ARDC Nectar cloud, and we got extra funding to add a GPU cluster, which certainly sped up the process of processing the data quite a lot. This is an example scientific workflow that was built on this platform. So using an orthophoto mosaic of, in this case, a geological surface, you can see the scale on this image. It's about 150 by 50 meters, and the idea here was to analyze the fracture pattern and then do calculations on this about connectivity of these fractures. This is relevant for studies on aquifers or storage media for underground storage of gas like hydrogen. And by being able to map the structures like this with a drone and then calculate the connectivity and map the connectivity of the network, helps assess whether this is a suitable reservoir, or sometimes it's also used as a model for something that's further underground. But anyway, this what we could show was that something that usually would be very laborious, a lot of tedious work, manually tracing mapped fractures, became a very smooth process by running this on this platform. But the open question that we've encountered was at the end of the workflow, the metadata. So in this archiving and publication step, we asked the question, which metadata do we need to capture and include in the archived and published metadata to really facilitate not only discovery of these data, but also reuse? Would that, well, the first obvious ones would be geospatial information, like the like of ISO 19115, and sensor observations like ISO 19156. But that doesn't describe the processing of the data in sufficient detail. So the open question that remained in the ASDC project was, what metadata do we need to add besides anything geospatial and the sensor observations themselves? And this is why I hand over to Alice.
Yes, so yeah, to continue on Jens' question, so we had this little project with NERC and UKRI, which is a UK Research Innovation, and the NERC, so the Natural Environmental Research Council. So they had a small project that was on digital research infrastructure, and with a specific project on imagery and derived data from autonomous and remotely piloted aerial vehicles. Next slides, please. So the goal of the project was to develop a workflow for data generated from UAV that complies with the data commons approach. So next slide. Yeah, so as part of this project, I won't go into all the details, but what we did was to understand the needs, challenges, and vision of the UAV community. And to do that, we ran different surveys. We attended the NERC, Net Zero Airborne Capability Group on uncrewed aerial systems, that is called NZARC. And we interviewed different scientists from the NERC community from different domains who are using drones. Next slide, please. And what they wanted to do is to add their data easily discoverable through a common data portal and be able to run computational analysis directly in the cloud using computational notebooks or Google Earth Engine equivalents. So this is a lot like what Jens presented. So we are in the same kind of environment, but what we discovered as well is that the metadata was the piece missing. And what we did is not develop the infrastructure yet, but what we did was, as a first step, really work on the metadata side of things. So this is what I will present now. So next slide. Yeah, so to harmonize the UAV metadata, we did not want to start reinvent the wheel. So what we decided was to base our work on existing work from the Environmental Data Service. And this is kind of a group of data center, including the UK Polar Data Center, the British Oceanographic Data Center, but also CEDA, EIDC, and NGDC. So these are all the UK NERC data centers. And within the EDS, we have expertise in urban data management with, for example, FARM, which is the UK Urban Laboratory, or the ARF, which is the Urban Research Facility. And we have also collaboration with the UFAR, which is the European Facility for Airborne. So it was just taking not only the expertise from the drone community, but work from the airborne community, which was much more developed. Then we had domain expertise as well, and expertise from the marine autonomous vehicles. And we also based the work on existing work from the international community, such as the results of this interest group, so the interest group on drones from the RDA and ESIP that was already presented previously, and so the publication that was part of this. And then we had a survey, and we had a different interview with scientists within NERC. So next slide. Yeah, so what we have discovered is that we have a different type of metadata, and we can't put everything on the same standard. While the UK Gemini metadata standard, which is kind of the ISO 19115 for the UK, is for discoverability. If we want to reuse the data, we need much more metadata than just this. And so what we came up with is that we have added some specific UAV metadata, which comprises common UAV metadata or minimum information required to describe any UAV data. So that includes, for instance, information about the platform, so the payload, the stability of the platform, the sensors that was attached to the UAV, the calibration parameters, or if the calibration has been done, what were the results, and then it was also any information as a community needed to assess the quality and understand the potential bias of the data. And then we identified two main groups of data coming from drones, or they are from drones. So the image and the non-imaging sensor data. And then for each of these groups, we came up with specific metadata. So if we had an image, so it was every metadata that were linked to the image, so the image type, the processing, or the resolution, and then the non-imaging sensor metadata, such as the variable or the processing information. And here we might need more information on what we need really for the processing, but this is the first step towards this. And then we have the domain-specific recommendation, or what is specific to the work that the drone is doing. So this is more related to what Simon was, for example, presenting earlier, where he needed specific metadata for his work. Yeah, next slide. So for each kind of different information, we came up with a list, and we came up with also, we rate them from recommended, mandatory, so R for recommended, M for mandatory, C is for conditional. So that means that if you have image data, then it's only if you are collecting image data, and if you are non-imaging sensor data, it depends on the type of data you are collecting. And then O for optional. So the slides are available, so I won't go into all the details, but basically you have information about the platforms and the sensor types, then you have information about the survey itself, so the geographic information, the weather reports, the dates and time of the flights, and then the sortie, so where the coordinates of where the drones went, and then it's metadata linked to the imagery or the non-imaging sensor data. Next slide. Yeah, and all this metadata is only available if we do record them well at the data collection stage. So what we wanted to do is to help the scientists as well on the field when they start to collect data. So we have come up with a suggested templates for collected when they are collecting the data. So at the beginning of the survey, you have like a UAV summary data collection sheet where you can record the project, the survey name, the geographic extent. You can then insert a map and give a summary of the survey, but then you will give information about the platform and then describe each sensors. And you might have during a big survey, different configuration, and this is what the UAV survey log sheet will do. So you will just list the list of sensors that you are using in the specific configuration you are using at the time, and then you can comment and put the time and like kind of have a event log of what is happening during your flight. Yeah, so this is used to then in the reporting periods that when you come back, at least you have this information from the data collection stage. Yeah, so this was everything that I have to say about what we have been doing. So we have come up with 2 reports that have been published online. So we have a report from the project, but also the guide for users where you will find the templates for the data collection and the list of, all the metadata fields that I've just described. Yeah, so that's it for me. And now I think we are up for a discussion of the priorities of the working group activities as the future direction of the interest group. And this is, I think, when we come back to the Menti. And this time I will try to also put the link of the real voting. Yeah, I think this is the first link because the second is for the slides themselves, but yes.
Yeah, so I put the link in the chat there. So we have 2 more questions, 2 brief questions, just to kind of start this the discussion part of the session. So we've gone slightly over time, but we did start slightly late. But I think we still have enough time to do for a useful discussion. So I put the link in the chat to this Menti.
I think it's the first link because the one you sent, I think, is for the slide. But yeah, anyway, you will get there, I think. And so, can I share the slide maybe? Yeah.
So yeah, so the first question then is just a couple of questions here just to kind of start the discussion. So based on also worth pointing out, if you do have any questions for either Alice, Jens, or Thabo, based on what we've presented already, please feel free to unmute your mics now at this stage, or if you want to add them into the Menti, or please add them into the Zoom chat. That's perfectly acceptable. Okay, so yeah, so the first question on the Menti then is biggest challenges with UAV data. So I guess I will invite Alice, Jens, and Thabo to respond to this, since this is far from my area of expertise, but a couple of responses in, one on metadata, which is quite succinct and to the point, I guess. Data interoperability with interoperability with other data types, so surface and remote sensing. Publishing size, so the image data size, then I guess in terms of publishing that is another issue someone has mentioned. So I think people should have a chance to enter in a couple of responses here, as far as what I'm seeing. Yes, you can submit more than one response, but thanks to those who have submitted so far.
Yeah, and I think anybody who wants to jump in and to add some comments is welcome to do so. So because this is the part where we talk all together. But as it's an open question, I think we can wait a bit just 30 seconds more.
Oh, Graham, apologies. It says you can't add more than one answer. Sorry, I thought that was.
Oh, sorry, this is me who said it wrong.
That's okay.
You can put it in the chat.
Exactly. Yeah. Exactly.
So what I also want to add another question that I find challenging in our operations, and that's the transfer of data from the field to a cloud platform. Most of the time we have to come back home to then read out the SD cards and transfer the data into the cloud. But is there anything that can speed up the process? That would be interesting. Yeah, Graham, that's also a great question, how to transfer the metadata with the data. Would that be embedded or bundled?
Yes, I just wanted to say yes, there is a way that we can transfer the data from the drone. For example, for us, when we do the inspection, we used to wait to download this data from the drone once the drone landed, but we realized it was taking so much of our time. So, and sometimes it was now, I mean, it was causing a lot of errors because, for example, the data that we enter into the portal, the coordinate must be very correct. Let's say we attach a photo. That photo must be of that hole where we took the photo in terms of the coordinates. So we came up with a script where now we are able to, when the drone is up there and is taking a picture, it drops the picture somewhere and whoever is putting the coordinates can pick the picture there. So we don't need to wait for the drone to land and then we take the SD card. We can easily, while the drone is flying there, whatever is recording, it can put them in the shared place where whoever is on the ground can access it, and we'll continue. Thank you.
Yeah, so maybe can. Yes, Graham has a good point that in imagery, we need to know about not only the location of drone camera, but also the pointing angle, because we are working really 3D. Yeah. Yeah, so I will. So then it's the next question. Maybe Graham, you want to add any something?
I was just going to say, yeah, with regards to kind of imagery data, not from a drone perspective, but from at the moment static cameras. Yeah, we've been sort of looking at this in the NCAS data activity and kind of how to use existing standards to kind of embed this information inside the files. And certainly kind of the challenges are there of not only where your camera is, but actually what's it looking at and describing that and capturing that in a standards driven way is kind of equally as important.
Yes.
Okay, so
Yes,
the next question. So at least go ahead. Sorry.
No, go ahead. Like we're good.
Yeah, so I guess the next question then, I think this is the final slide, if I'm not mistaken. This is, yeah, so what would you like to see as recommendations from the working group? So I've linked in the case statement, or sorry, I provided a link to the case statement earlier on. So we have already the co-chairs have sort of given thought and time to describing the recommendations, that the intended recommendations at this stage. But as I said, the case statement is in community review stage, so we're still at the stage of kind of being open to any further feedback on that. So obviously, based on what we've kind of discussed this morning, or if people have had a chance to look at the case statement already, that would be great. But then if any people have sort of thoughts on what the potential outcomes or recommendations of this group would be, that will be this is the time to share it. Obviously, as well, I mean, as I said, the community review period is open for 4 weeks at the very least. So people will have the opportunity to kind of provide further feedback via the RDA website, the usual kind of channels as well.
And I might add that you can comment whether or not you are happy with the kind of type of recommendation we are suggesting of this group, or so this is also like a way for you to comment on anything you want to say, or yeah, about the recommendation, if you are still interested in what we aim to achieve.
What I'll do actually is just I'll just, put a link to I'll relink the case statement just for ease of access, but I'll also I'll link that into the chat. This is all the kind of links and things I've put into the chat here are available in the collaborative notes as well, just for reference. But what I will do is I'll kind of copy and paste just a bit of text from the case statement on the expected output. So we've kind of summarized these the recommendations.
So then I have added a last slide, I think yesterday, but it was also like, if you have any other ideas or things that you think we have not covered, and you saw that it was kind of the goal of the group, and you think that it's a missing part of what we are doing, but also if you have any ideas of collaboration or other projects or initiative you think might benefit from or contribute to this work, don't hesitate to put them in the Menti pool, and we make sure to liaise with, and it can be people, it can be groups in your institute, it can be also collaborators. So at the moment, what we can say is that we have each, like at least Sabo, Jens, and myself, we are trying to involve our own institutes and own projects. So I've been working quite a lot with the British Antarctic Survey, and we are at least trying to apply the metadata standards that we have been that have presented, and they have just been on the field with the templates. So now we will revise the templates as well to see what worked, what didn't work, and this is how we will improve also the templates and the outputs that we had as part of this project. And yeah, so if anyone wants to add any projects they are interested in, don't hesitate. I will just stop sharing so that we can all talk together and have a proper discussion. So maybe Graham, you wanted to say a bit. I know that you are working a lot with NCAS.
Yeah, so I'm going to be a bit controversial, if I may, which is to slightly challenge the group, which is why these so the SUAVs need a particular metadata standard as opposed to standards applied to other moving platforms. What's the distinction? I'm sort of being clear on that. I'm not a UAV person, so I'm asking that question from an external perspective, saying, why do I need to kind of have these specific metadata standards? Why can't I just pick up other ones we use already for existing aircraft, for example?
I think that's a really good question. And so my take on this is that if there's something that we can reuse, we should do that. And that's why we already want to have the working group work with other platforms to learn from them how they are managing the data and metadata and making them cloud ready. And so if there's something that we can reuse, I think that's what we should be doing. There's not necessarily a distinction, and it will be also I think a job for the working group to work that out, to see, is there a difference, or is there so little difference that it wouldn't make sense to do something separate? Or what is the difference? Maybe there isn't any. What I also see, having been part of this community for a couple of years now, is that it is still quite a fragmented community, because it's so easy to just go out and buy a drone and take measurements, that there's not really much coordination, and people don't know of each other, what they're doing. So with the two groups that we now have, the interest group and the working group, we can work on those, for instance, on those two aspects. The interest group for creating more connection between, at the moment, groups that don't know of each other, and with the working group to look at a more concrete question of how do we manage the data that come off these platforms.
So I suppose my question might go slightly differently, which is also, is this about kind of the piloting of the platform, or is it about the instrumentation on the platform? The reason I say that, piloting in terms of, if you have a crewed aircraft, for example, as opposed to an autonomous drone, again, comparing that to a piloted drone, there's kind of three different use cases. Two obviously have a human controlling and deciding, okay, it's going to go in this direction, and for particular reasons why. You might record that down. Hopefully you record the reasons why you fly in that direction. But the other case was it's autonomous. You've got some sort of an algorithm, some sort of AI aspect, and how are you capturing that?
Yeah. So I will maybe give a few comments on this. So there are still some differences, because now, for example, the drones are also used as swarms. So you have different drones also flying at the same time. So that might also add some challenges. And the payload might have much more impact than what you have on an aircraft, for example, in the quality of the data. Sometimes it's much less stable. And so while in some disciplines, the use of aircraft was already well established. So I will take, for example, the atmospheric sciences, but also in geophysics, we used quite a lot airborne capabilities to do research. And now there are much more like the use of drone is used in disciplines where it was not used as much. So the scientists don't have the same mindset in going into the field and making sure that they are doing things correctly. While on an aircraft, usually you knew that it was kind of an expedition, and there are things kind of standardized, and there are a way to do things. While now people are just buying a small drone, putting a camera, and they are going on the field. And this is where the challenge is. And I think this group might be a way to really build a community and to have people from this smaller group, like smaller use cases, might find some knowledge and could find answer to their questions. So this is how I see it as well, where while you have already a lot of expertise coming from the airborne road or from the marine autonomous vehicles, sometimes if you are just going to the drone field and you have no expertise from these two roads, you might not know what is best practices when you have a flying platform or moving platform also, right?
Yes, let me also say, because the drones also really what matters in the drone is the camera. The camera is the main thing that collect the data, and you'll find that these cameras, they are not coming from the same manufacturers. They are coming from different people. The way they capture the data sometimes is not the same way. And when people are capturing the same place or the same incident, you find that because of the altitude, they are flying at different heights. You find that the data is not just going to be the same, because it depends also on the skill of the pilot. Because sometimes when you are, let's say you are capturing a certain incident, we had a project where we're dealing with the police, where you need to capture, the speed also matters, because it depends on what you want to capture. But the whole essence is that sometimes it's very hard now to present that data in a platform or according to what the client wants. So I think the standardization will help in the sense of that, say, if we know that a data from a drone will come in this manner, it becomes easy to merge this data from different drones. But sometimes you realize that if you are using this kind of a drone, this data is going to come in this format, in this way. But when you use a different drone, it's a different case. And that is why even, for example, the project that I'm doing, that we are dealing with electricity, there are certain drones that we cannot use for this project, but they still have the same camera, they still have all these things. But because of the nature of what we are doing, there will be a specific drone that will be recommended, simply because I think the way they capture the data is not the same, and the security of the drone itself, it's different depending on the circumstances that you are operating in. Thank you.
So I see there's another comment in the chat from Graham. So thanks for that, Graham. So I know what we're coming up to kind of the close to the half hour. So I don't know if any of the co-chairs have a chance to respond to the comment that Graham posted, or if we want to kind of leave that as a potentially hanging question that we can address in the case statement feedback. Or Graham, if you want to sort of pose one final question.
Yeah, I had a very interesting case that kind of came up probably about 2 years ago, which is an interesting one. Has this one kind of mapped to the situation, which is it wasn't a piloted vehicle. It wasn't really an autonomous vehicle as such, but it was use of avians, pigeons, and kind of the flight path is completely uncontrolled, as it were. You release them, but you're sensing kind of you've got sensors strapped to avians that fly around, and then how do you kind of capture those data? And I think the reason I'm sort of flagging that one up here is because it's small packages. It's an unusual actual vehicle itself, but also it's kind of the swarm aspects as well. How do you kind of there is some sort of similarities in that aspect. It's very unusual. I don't see it happen very often. You're going to get these cases, but I think it'd be interesting to see how the output of this group would actually could have helped us back then.
Yes, thank you anyway, Graham, for all your comments. This is at least pushing us on finding and see where we want to go as well. So thank you for your questions, and yeah. So you are welcome to join the working group as well.
Yes, please on that note, I think we might be time to wrap up. So what I'll do, we do have a very final slide, but I'll just paste the text from the slide rather than sharing the screen into the chat here. So as Elise said, yeah, please, Graham and Dylan and others. Well, there's no one else here at the moment, but we will be circulating this further. So the working group is now set up on the RDA website. So please feel free to join that, whether you want to kind of join as an active member to contribute, or whether you just want to be kind of kept up to date of the working group's activities. The more people that we've joined, the better. And as I said as well, the case statement is now in community review period, so that will be sort of plastered on the front of the RDA website, and a link to the document will be available. So that will be open for, it's usually about a period of 4 weeks, might be 5, given that it's kind of starting at the start of the plenary period. But yeah, we welcome all. Thank you for your comments today, Graham, and for joining us, Dylan, and the other attendees. So any further kind of feedback you might have on the document itself is welcome. So please feel free to have a look at that at some stage over the next 4 weeks, if you can. And yeah, I guess seeing as we're kind of a minute past the half hour, we'll wrap up. So I'll just thank again Jens, Alice, and Thabo for the presentations, and thanks everybody for joining us. And as I said, the recording of this will be available on the Google platform pretty soon. I think it's very quickly, maybe it's instantaneously. So we'll be free to watch back, and we will be having another session next week. So if you know of any colleagues who might want to join us, please feel free to just find the next session on the agenda and direct them, point them in our direction. So unless anyone else has any final words, I will close the session and we can get on with our mornings or afternoons.
Thank you.
Thanks, everybody.
Thank you, everybody.
Thank you very much. Very interesting. Cheers.
Bye-bye.
Bye.